Okay, now we're going to work on a concept that's a little bit similar to length of arc that we saw on last page, except now we're going to talk about the actual area. Remember, the formula for area of a circle is pi r squared, and we are going to see that here as we do these problems. So remember, the area of a circle is pi r squared, and so if we're going to have a fraction of that circle, it's going to be a fraction times pi r squared. Here there's a little investigation where they talk about a sprinkler covering the center of a lawn, and it sprays water at a 20-meter distance, and it rotates to a certain angle. Basically, it's going to trace out a pizza slice. Okay. And depending on this angle, you can figure out how much area of grass it covers. Find the area of the garden lawn that can be watered by a sprinkler if it is set to rotate at an angle of 180 degrees. That's a pretty easy one. It would be 1/2, because 180 degrees is half of 360, times pi r squared, right? Pi r squared in this case would be pi times 20 squared. So it'd be 400 pi, right? Find the area of a garden lawn that can be watered by the sprinkler if it is set to rotate an angle of 60 degrees. So 60 degrees is divided by 360 degrees is 1/6 of a circle. So it's pi squared. You could just write 60 over 360. That's fine too. Find the area of a garden lawn that can be watered by the sprinkler if it is set to rotate at an angle of 1 degree. So that would be 1 over 360 divided, or times pi r squared, right? And number 4, find the area of the garden lawn that can be watered by the sprinkler if it is set to rotate at an angle of alpha. So that will be alpha divided by 360 times pi r squared. Okay? That's what we've been doing all this time. We just put the angle over 60 and we multiply it times pi r squared. We make a fraction and then we multiply it times the area of the entire circle. Okay? So, number 5, find the formula. We've already done that. It's also written here. Okay? Remember, this formula is if you have the angle in degrees, which we always do in this class. All right. Determine the areas of the sectors with, and remember, the pizza slice is called a sector, and we're finding the area of the sector. Determine the areas of the sectors with radius r and the center angle theta given below. Give your answers correct to 3 significant figures. Okay. Move this up. All right. R equals 6 centimeters and theta equals 70 degrees. So that would be the formula is theta divided by 360 times pi r squared. So in this case, it would be 70 divided by 360 times pi, and r squared would be 6 squared. So let's put that in the calculator and solve. So this is a fraction. I think I'm going to use the math. Go to math, number, go to the bottom, and we're going to put 70 times pi r squared, which is 6 squared, could be 36, could put 6 squared, and in the bottom I'll have 360. And I'll put, and the answer is 21.99. It says 3 significant figures, so 21.9. Would we round up the last 9? Yes, because the next number is also 9, so it would be 22.0. How do we make it 3 significant figures instead of 2 significant figures? We put the 0.0 after, okay? All right, a sector with central angle 140 degrees and the radius 9 is cut from a wooden circle. Find the area of the sector. Okay, so they even drew a picture for us. We don't even need to read the text. So basically this thing here, we're going to put the angle 140 degrees divided by 360 multiplied times pi r squared. So it would be like that. So we're going to have, I'll do the vertical fraction again, 140 times pi times 9 squared on top, 140 times pi times 9 squared on top, And on the bottom, we're going to have 360. And the answer is 98.96. Okay, if we wanted to do 3 significant figures, it would be 99.0, right? Because the 9 would round up to 0. A sector with radius 10 and central angle x degrees has an area 48 pi. Find the size of angle x. Okay, this is a little bit different because they did not give us all the information in the formula theta 360 over 360 pi r squared. They didn't give us the angle. They gave us x instead. But they did give us the area, which is 48 pi. So instead, what we do is we put the area, we plug that into A, 48 pi, and then we set that equal to theta, which instead of theta, we're going to put x over 360 times pi, and then instead of r squared, we're going to put 10 squared. Okay? And so now we got 48 pi equals x over 360 times pi times 10 squared. And this is basically an algebra problem. You can isolate all the x by multiplying both sides by 360, and then you'd end up with 360 times 48 pi, and then you'd cancel that 360 out, so it would be x times pi times squared, which is 100. You could divide both sides by pi 100, and then you would end up with 360 times 48 pi divided by pi 100, and then you could just cancel out the pi's and then do 360 times 48 divided by 100. Another way you could do it is you could use the solver. So how do you do it with solver? You press math, and then you go down to the bottom of math, and there's solver here, and you put the side, which is 48 pi into E1, 48 pi into E1, and then you put, oops, not 48. That's weird. 48 pi, so you do second that, okay? And then on the right side, you're going to have x times pi times 100 divided by 360. We're going to use math. Oops. And we're going to go to the vertical fraction. And we're going to put x times pi times 100 divided by 360. And then we press OK. And so we have our formula input into it exactly like it is here, right? Except for instead of 10 squared, I already put 100. And then I'm going to say, okay, let's solve for x. I'm just going to press alpha solve on top of this value for x. 0 is the starting value, and they say that the answer is 172.8. So if I do 360 times 48 and divide it by 100, I also get 172.8. So let's just demonstrate that here. Okay, so 360 times 48 divided by 100. Oops, that was divided 10. We got to divide by 10 more because we're supposed to divide by 100, not by 10. 172.8. Okay. All right, that was for page 2.